Okay, before the break, I asked you a question about which program I was using. Wait a minute. I asked you a question about storage, which is you see that here I define the class storage, public target. I define this class. And then I have this um, class item and storage. I put it in front of this two line. I want to ask you what were these two lines doing in this piece of code? Storage. You can actually go to the website. I'm sorry, I should have told you to go here to check. If you come over here, storage is right here. Storage.h. So you can take a look at, I have two lines, line number 9 and line number 10. I only declare class item and then semicolon without anything. What was the purpose of this two line? Any idea? Okay, the way to find out the answer. Okay, I mean this question could be pretty challenging if you never saw this. But the best way to answer my question is to try to remove this two line and see what happened. Okay, so let me remove this two line and see what happened. Okay, I remove this two line. So let me compile it. Okay, you see that now I have this problem. It says that in the item.cpp, in the item.h, it says arrow use of undeclared identifier item, which is in storage. Okay, so the code item.h, let me actually take a look. Let me tell you what happened. What is item.h? Item.h, it will include storage.h. And inside storage.h, which is we show you earlier, it actually is the code we saw before, and I have commented out this two line. All right, and then let's take a look at the error message again. The error message says that is use undeclared identifier item. Okay, undeclared item. Why is that? Okay, let's take a look at item.h. Inside this code, I'm supposed to declare class item, but I haven't done that. You see, the compiler first have to deal with this three line. And this line is storage. So before the item was declared, I'm actually trying to compile the storage.h. I try to declare this. I try to parse storage.h. And inside the storage.h, inside the storage.h, because of the item, you see that I have a recursion. In fact, it's interesting. I actually try to include. Okay, I won't actually go this line because when I go to item, I will go to storage. But when I second time enter item.h, because I have this two protection line, this is the same two line that was in item.h. So the second time I enter storage.h, I'm going to neglect this line. And then inside this one, I'm going to hit one of the variable, which is here. I'm actually declare a vector of item. And then because the item hasn't been declared yet, the item hasn't been declared yet. So I ran into that arrow, right? So essentially, let me summarize what I just showed you. I enter a declaration for the class storage. And inside the storage, I need to have something called item. But the item hasn't been declared yet due to the order of the compiling architecture. And therefore, I cannot do that. And therefore, I need this two line to be able to handle that. By the way, this this is not unique. This is because storage and item, they are mutually referred to each other. So over here, you see that storage is a vector of item. And then if you go to the item, it actually shows you where do I store it. It actually asks us to storage. Okay, so now you can see I have two classes. One is item, one is storage. They access to each other. And which one should I declare first? Doesn't matter because it's a what I call a deadlock. The item need to use storage, storage need to use item. And therefore, I have to put this two line to say, hey, I have this two class. I won't tell you the detail, but now I just declare you have this class. And that's the reason I have to change this back. Let me show you. If you go to storage, that's why I need this two line. This two lines essentially, I'm telling the compiler that I will declare a class called item at some point, and I will declare a class called storage at some point. So this basically, I'm telling compilers say, hey, even though you haven't seen I declare item, but it will appear later in the compiling process. And don't worry at this moment. So the compiler need to see this two line before it can actually allow you to compile everything successfully. Okay, so I want to actually just put a comment here. This is because item and storage mutually refer to each other. You can think about this happen a lot. Okay, so that's the tricks that you need to first. You should know as a C++ programmer that you need to know to put this two line in order to make this work. Okay, this is number one. Number two, now you might hate me for doing this all the time. I said, well, why Professor Wu not directly say item and he want to use item star? Now you see that a lot of places I'm using pointer instead of using the object. You're wondering why do I just because I like pointer? I mean, nobody likes pointer, okay? In C pointer, nobody like it, including me. Let me show you something. If I get rid of the star, this is the original code. If I get rid of the star, something looks like this. And I get rid of this star as well. I'm just making the content is a vector. Now I try to make. I hope I'm right. Wait a minute, it still work? Okay, I took whatever I said in the past 5 minutes back. Okay, let me see what happened. This is embarrassing. I thought I'm going to see an error message. What did I do here? I said this is the item. Huh. Okay, this might be a different version of C++. I'm pretty sure in the older version, the way I wrote it here, it won't work. The reason it is that because oh, I know. Okay, if I do this, would that be okay? Let me actually try one more thing before I conclude my mistake. I said this is XYZ. Let me see if this is okay. Yeah, okay. You see that? If I don't use star, if I declare item XYZ, and it will say it has an incomplete type item. Why is that? Let me actually tell you that this is the second lesson I want to tell you. If I do this, I have an arrow, but if I change this to be a pointer, if I change this to be pointer, then I don't have a problem. I can compile everything correctly. So this is the example. Okay, I myself learned something new. The difference between these two are one is I have item directly as an object, and the other one is item star. So this is, again, we talk about memory allocation because whenever the compiler compile the whole class, I need to know the memory layout. I need to decide the memory layout so I can process further information. I mean, at least I need to know how big the object is. But for the item, I don't know because I'm just declared that class item. I said, hey, at some point, I'm going to tell you what item is, the detail. But at this moment, I just tell you I have a class called item, but without telling you the detail. So that's why it's called incomplete type. This one is I declare as a type, but it's an incomplete type because I don't know the memory layout yet. Okay, if I declare item star, why the compiler can do that? Because it's also an incomplete type. Because what is a pointer size? The pointer size is 8 byte. And therefore, if I declare XYZ as a pointer, so what the C compiler really think about this is it's a pointer. It's not a type item. Therefore, I don't need to know the type, the number of bytes. That's why you see me a lot of the time, if I have this kind of mutual reference to each other, have a two class reference to each other, I always use pointer so I can compile things correctly. The reason the vector works because it's a template. Inside the template, it must also use pointer. It's not using the type. It's just basically is a vector, is a template to allow me to put one type to the other. So therefore, even though I declare it's a standard vector item, but the code around vector already convert that into something equivalent to pointer. That's why over here, if you do item star and item, it doesn't matter to the compiler. Compiler can figure out that is a pointer kind of type. Okay, so this is one thing I want to tell you. This is two things. One is you have to understand how do you deal with mutual reference in C++. You want to have two classes, they refer to each other. How do you break this circular dependency? So you need to have this two line to handle what we call incomplete type for mutual reference. This is just a declaration and without the detail. Okay. And then the second thing is if you have a mutual reference inside here, you cannot directly access the whole object like this line. You cannot do that. We cannot because we don't know how many bytes. We don't know memory layout for item at this point. Okay, this is the reason. That's why you have to do that. That's why, in fact, a lot of my code, I did, by the way, before today, I didn't even know that the vector is already convert the type to the pointer. So that's why I actually try to use pointer whenever I must use pointer when I have a reference, what I call mutual reference in my class design. Okay. All right. Any question? All right. Good. Let me go back and before I can start talking about the template in general. Let me get rid of this. Let me compile again, make sure I'm okay. So the other lesson I want to tell you is that it's always good whenever you deal with a large, complicated system. When you saw a line you don't understand, it's always good to remove it and then see what kind of compiler error, and then you will learn from that process. Okay. All right. So let's go back to. We're almost done with this YSD. I want to just finish this YSD before I move to, so you can actually learn how to build your own project. So we were here in the fridge, we're here in the transaction, we're here in the grocery store, we're here with the product. Okay, and then we have a product called beer, which beer is an item. Okay, here's a product. The product basically includes all the information specifically for this specification of the product. And then we have a real item, which is the beer, which is the one that's actually currently I have a beer is actually this particular product. And ratio 1.0 means that whether this beer is fully is not being open is 100%. And then you can see that is this part is interesting. I'm actually using the intention about purchasing this product. So if I have an intention to purchase this product, then I specify my intention of purchase using the current and the next. So every item has a current location, has a next location. So essentially when I do the purchase is transfer from Nugget's fridge to my fridge. So let's look at the item. I almost forgot what I did with my design of item. So this is the item. And oh, you see that? I have the item I actually defined, the current and the next. Both of them are storage. So essentially, I want to use my item to be able to describe my intention. That's why I actually designed this two argument attribute. One is called current, one is called next. That's actually helped me to identify this one. Okay. I hope you understand this, the motivation for this design. And then I can check, okay, here I didn't actually implement. I just say if the product has a keyword alcohol, then essentially I need to check the credential. I didn't implement the credential part. I'm supposed to check this person's age or this person's health condition. Okay, then if this check pass, then essentially I'm going to send the coupon. And the coupon basically say, hey, you can use this coupon, this discount within the next 7 days. So I actually increase today's day plus 7 days. So I just remember JT is I get the current time and then I make the day plus 7. So it means that I can use this coupon within a week. And then I create this coupon. For example, the first coupon looks like this. The coupon basically say, hey, it's a coupon, and then you can use this coupon at the Nugget Market, and you can use this for product number 1, and then this one will give you the price is going to be 0.75. Okay, and then you see this part is interesting. How do I deliver the coupon? I'm actually using message. So who is P1? Let's take a look who is P1. P1 must be a person. Yeah, P1 is the person, the father of the household. I guess he's mature enough to purchase the beer. And this is the P1 has been declared. And let's go down here. And essentially, the way I deliver a coupon is I'm actually sending a text message. I'm actually sending a text message. And how do I send that text message? I'm just C1, which is the coupon. I do a dump to JSON. Dump to JSON will return a pointer, and then I deliver that coupon as a message. So you can go to the message, go to the person. Let's go to the person. Inside the design of the person, that you have a particular function called inbox. You have a function called inbox. And inbox is a multi-map. Multi-map meaning that you could have the same string with the same key with multiple items. And inbox is like an emulation of somebody's text message inbox, and which you can actually have a key and then have this. And this inbox, you can use a function called message. And this message, let's take a look at the message, how message is implemented. So essentially, you're creating a messenger type of environment for every single person. Okay, here is the message. So the message interface is very simple. It's just take one parameter, is a JSON. And then you will check whether you have a subject, whether you have the correct format. And if it's okay, then essentially what you do is you create a message. And then what I did is I convert using JSON to object, convert that JSON into a message object. And then I do the inbox, I do an insert. I insert that message into now I have another template called pair. I basically insert this string and a message into this template, into this inbox. In this case, I'm actually going to fulfill my message. So the message is quite useful because this is a very simple design for you to have any kind of communication among person. You can use this to do that. Okay. Go back. So you can see that here now you walk into the store and there is a coupon, and then they realize you have an interest about this product called beer. And then the way they deliver the coupon to the person is via the messaging interface. And then you will get that, and then you can actually handle whatever your inbox from your application. It will pop up, and then you decide whether you want to use that coupon to actually fulfill the purchase. Okay. All right. So this is essentially the rest of the code is just handle the exceptional handling using EE1520. So hopefully this particular example gave you the idea about how you can quickly to use existing classes and using the function we provide to actually come up with something which is quite complicated. This scenario, by the way, is quite complicated. It talk about smart fridge, it talk about purchase, talk about coupon, talk about credential checking, and you can create your own scenario and then to prototype something which is rather quickly. And if you, let me just compile everything again. If I run this /YSD grocery, And then you will see that at the end that this particular coupon, this is the for diaper. If I go up a little bit, this is the coupon that being delivered to the person at the time, and it has you see that the time is automatically figured out because I was using it. Oh, come on. If you take a look at this is pretty accurate because the coupon is valid for 7 days. Today is June 5th. Whatever time stamp it is. Oh, that's interesting. This is California time or whatever time it is. And it will be valid for 7 days, the coupon that will be useful, just issued from my computer. Okay, I'm going to stop here and then now I'm going back to the function template. Okay, I'm going to talk about the template. So in template, I have three things to cover. One is called function template, one is called lambda expression, and the other one is called class template. Is all has to do is how do I declare either a function or a class in a way that I can have a general way about developing this. So I'm going to start it with the function template, which is the easiest one. I already showed you, by the way, the last topic, STL, standard template library. In fact, we talk about STD map. So the third item is already done. I mean, I want to cover the first two topics. Okay, so first I want to show you an example. This is a piece of code. I want to move this a little bit here. I don't want to block the view. Okay, so look at this orange box and the yellow box in the bottom. Okay, I have a two function. They're both doing what I call comparing two value to decide give me the less value. Okay, for example, two integer return me the smaller integer, which is the a. So in this case, you can see that this function is input is two integer, return is an integer, and it will return if a is smaller than b, then you will return a. Otherwise, return b. But by the way, I'm not sure you're familiar with this syntax. Are you familiar with this syntax? The question mark and the column. Have you seen this before? Last quarter, last semester? Okay, good. So some of you say yes, so that's good. Okay, I'm not going to repeat. This is just another way to write if then else. Okay, by the way, I don't know why. They just make things more complicated. Okay, by the way, that's the one way. Okay, the other thing is that I have another function, but I'm not comparing two integer, I'm comparing two double. So the still I call the minimum, but the input is a double A, double B, and return a double. And the code looks like the same. It's a return A smaller than B and the A column B. Okay, so this two program, this two function, logically, they're identical. The only difference is the data type. Other than data type, they're the same. So that's exactly we want to develop a template. We want to say, okay, the logic is the same, but sometimes you want to compare different kind of object. Sometimes you compare integers, sometimes you compare double, and sometimes you want to compare two GPS location. I mean, if you can compare GPS location, which means you want to do operator overloading in this operator smaller than, then you can compare two person, you can compare two object, two GPS or whatever, to whatever you want to do. So this is the idea. We want to have a template. And the way to do template is then the only thing we want to parameterize is the data type. So then this is the way I declare a template in the green box. So take a look at what I did. So this is the declaration. So this is how I declare. I declare template, and then I have a type name T. Type name T. And then inside here is capital, the red letter means that it has to match the red letter over there. And then essentially you see that the function declare is no longer a specific type, but is a type name T. So essentially, this one will return a T, and minimal A is a T and B is a T. You compare A and B. The rest is the same. And then when you want to do this is the way to use it. When I want to, this is the declaration about the template, and this is when I try to instantiate from this template a function. So when I want to call this minimal double, the double version, I just basically put the type name double, and I can say x to the 2.7. Does that make sense? So essentially, you don't need to write this anymore. You essentially just write this, and it's the same thing for this one. Let me actually do it the other side. And over here, I would just say minima, int, and then x and y. Okay, if I do this, then essentially if I write this template, when I want to call the integer version, I will do this. If I want to do the double version, I'm going to do this. Okay. All right. I'm going to use this example to tell you that this template example, I only have a one type name T. I can have multiple. I can have multiple one such that I can make this function to be say, hey, over here, the reason I have only one type name, because all three happen to be the same type. But what happens if I want to return not the integer, but I return something else? Then you can have multiple type as well. Let me actually see if I have a more complicated example somewhere. This one is not, oh, this one I show you, you can do a GPSDD, that's fine. And oh, okay, this one is a general declaration about the function template. You can see that I could have a function which is a template with a three type name, T return, T argument 1, and T argument 2. And then when I declare the template function foo, this become T return, T target 1, and T target 2. And when I call the function, you see that I'm actually calling a foo with a three type name. So I'm actually calling, the return is going to return a JSON value star. And the first argument is going to pointer to a person object. And the second object is a JV times star. And then I take this two pointer over here. So this is the way how do I declare, and this is the way how I can actually really instantiate to use this function template. So essentially what I'm talking about here is that I can have a template such that I can, at the time when I use this template, then I decide what should be the data type I should put in there. And it's very convenient. You just need to define the function once, and you can use it multiple times. Okay, let me show you a more complicated example. I have this template I call it is in range. Okay, this function called is in range. And this one has, I'm going to say okay, by the way, this is another thing I need to tell you is that sometimes not only you can not only provide a type name, but sometimes you can provide some kind of value as well. So this is a good example for you to know is the function template, you can parameterize not only the type, but we can parameterize certain value into the type as well. Okay, so this is a function, a function template or function is trying to say whether you are within the range of this GPS location or within the range of two double or whatever. So what you did, look at this. This is an example. This is the function intended I want to do. Your input argument is a double. And then I want to see whether this argument value is smaller than 500 and is greater than 0. Okay, I want to see the range is 500 and 0. You will see this kind of code a lot, this kind of logic a lot. However, the value of the number, the range might be different. For example, the blood pressure might be one thing. The normal temperature may be something else. And the stock price may be something else. So, but they all have this concept called range. So I can actually declare a template range, which I can also parameterize the upper and the lower. So I gave two range, the maxima and the minima. And inside the range, I basically say argument value smaller than upper and argument value greater than lower, something like that. So this is the way I declare the template. But then when I call it, I'm actually directly call is in range. And then inside the template separator, I said the first one, it need to be double, means the argument to the function need to be a double. And the upper is 500, lower is 0, and then you have this. You can call this, and this is the equivalent to call this function. Okay, this is essentially the compiler is going to generate this particular code based on this template, based on this instantiation. Okay, so that's another way. So you can see that this is pretty powerful for you to write very nice code, and you can reuse this template again and again. Okay, any question for this? All right. So I hope you understand the template. Now I want to introduce you the next topic called pointer to function. So I have mentioned this concept a few times, but this concept, I think that finally I got a chance to introduce you more detail about this idea. So essentially, it's you can think about what is a data with a function. Usually you think, okay, the function is a segment of code, and the data is a segment of value somewhere in your memory. In fact, in modern computing system, especially if you're using C or C++, your function and your data are all together in the same piece of memory. Okay, they're the same. So what I'm saying that sometimes the data can be treated as a function. Sometimes your function can be treated as a data. So this two, the boundary is blurred. So they can be called. I mean, one of the example you have learned is called virtual function. So virtual function is a function, but how do you control the virtual function? It's a data. This is the data we call a vtable, virtual table. Inside the vtable, you have a pointer to the function you really want to call at runtime. So the reason you want to have a pointer function is that such that I will be able to handle certain thing at runtime. So I want to declare the template to function, that was a compiler concept. But now the idea of a pointer to function, in fact, is mostly is a runtime concept. Okay. So first, I want to tell you what is a function pointer. A function pointer essentially is a memory address of the entrance point about the function. So that's the representation. So whenever you call a function, that function has address. Okay, so you can print the address of a function fairly easily. So let me show you an example. First, I have to declare, you have to know how do you declare a pointer to a function. All right, so this is the way to declare. So this is the syntax of declare. You have to, let me actually do this way. Let me go back. Let me copy this. Okay, let me just take a look at this. So I want to show you how do you declare a function. I don't need you. How do you declare a function? This is usually the way you declare a function. The top is how do you declare a function, which is you have a return type, you have a function name, and then you have a bunch of argument. That's how you declare a function. Declare a member function or function, that's how you declare. And if you compare this two, the only difference is that I replace the function name with a pair of parentheses and with a star and a name. Okay, so let me actually make it another interesting. Okay, now I have a three thing. Let me not call a function pointer, I call a function X. I don't want you to confuse that I have to call a function FTR. I can call it anything I want. Okay, so I want to show you the three things. The first one is just a regular function. I know what I want, what I should do. I should make this also function X. I want to compare these three things. The first thing is I declare a function and the return type is T return, type return, whatever. And it's a function name. And the third one is a declaration of function pointer, which means that FUNC X is a pointer to a function which will have the return type T return, and then the input argument is list of T argument. Okay, so fun underscore X in this way is declared as a pointer to a function with certain return type and with certain list argument. But this one, in fact, is not a function pointer. This one is the magic about why you have to have this parenthesis. This one, essentially, the star will go with T return. So fun X is still a declaration of function like the first line. Instead, it's a return type is not T return. Instead, it's a T return star as a return type. So I want to tell you that the syntactically, this one is over here. Okay, so this three, I hope you different. The first two is not function pointer. This one it is. And this one has some example, but I will continue this Monday. But I want to tell you that at one of the GitHub, if you look at CPP15 function template under SVLX rule CPP15, it has all the example about function pointer. For example, function pointer example is here. You can see that how I declare, oh, this is a template, function template and the function pointer. You see that? This one is the function pointer. I declare here in line 12. Okay, so we will continue to do that. If you have some interesting stuff you want to take a look over the weekend, you can take a look at this directory. Okay, see you.